Hello everyone, welcome back to Vedantu Malayalam channel. How are you guys doing? Hello everybody. So today we are back again with determinants and lecture number 2 where we are going to learn about adjoint of a matrix, inverse of a matrix and application of determinants and matrices. Alright. So in yesterday's class, we basically learned what are determinants, why do we use them, what are their special properties, how do we apply determinants in finding area of a triangle, and what are minors and cofactors of a element inside a matrix, right? Now today's class you are basically going to learn the application of minors and cofactors in finding adjoint of a matrix, inverse of a matrix and some other application as well. All right, so yeah, let's begin the class. We will be learning about adjoint of a matrix first because this is used in understanding inverse of a matrix and inverse is used in applications of determinants. All right. Okay. So if you're somebody new on the channel, quickly subscribe for your physics, chemistry, mathematics and biology regular lectures, and we will be here to help you out in every way possible for your +1 and +2 preparations. Okay guys, let's begin with the very first topic. What is adjoint of a matrix, right? Now, suppose we have a matrix B, okay? We want to find the adjoint of this matrix. So what is adjoint? It is nothing but transpose of the cofactor matrix of B. So basically, suppose you have a B matrix which is of order 2 cross 3. That means it is having 2 rows. So A11, A12, A13, A21, A22, A23. It is having a 2 rows, 3 columns. Now, if I find cofactors of this matrix, so cofactor of B will be having elements C11, C21, C12, C13, C22, C23. These are the cofactors of the given matrix. Now, simply what is adjoint of B matrix? Adjoint of B matrix is transpose of cofactors. So you have cofactor matrix, just transpose it. Rows become column, column become row. So first row will become first column C11, C12, C13, C21, C22, C23. So the first row becomes first column. Like that we do transpose, right? Now this is adjoint of matrix B. Understood everybody? How do we find adjoint? Similarly, if you have a 3 cross 3 matrix, so suppose a matrix has elements Aij. Now, what is the cofactor of Aij? Simply C11, C12, C13 and so on. Yesterday we learned how to find out cofactor. Now, what is adjoint of A matrix? Adjoint of A matrix will be transpose of cofactors of the given matrix. Alright, understood all of you? Cool. So this is what is adjoint of a matrix. Let's do one question. Find adjoint of A matrix where A matrix is this. First of all, we will find out Cij. That is cofactor of the matrix. What is the cofactor of 2? It is 4. What is the cofactor of 3? It is 1. What is the cofactor of 1? It is 3. And similarly, cofactor of 4 is 2. But we have to take care of the sign also. So how do we determine sign? This will be positive, 1, 1, 1, 2 will be negative. So it will be minus 1. Similarly, this will be negative, this will be positive. So Cij is this. Therefore, adjoint of A matrix is transpose of Cij matrix, which is basically row becomes column, column becomes row. So this is my adjoint of A matrix. Alright. Now, I have a shortcut for all of you. Very important shortcut which is highly used in your CUET exams or any other competitive exams. Generally, they will give you a 2 cross 2 matrix. Okay. This shortcut trick is applicable only to a 2 cross 2 matrix. What is the shortcut? If you want to find adjoint of a 2 cross 2 matrix, simply interchange elements of the primary diagonal. Like the first diagonal, interchange the elements. How will you interchange? This will go here, this will go here. Okay. So here you will have A22, here you will have A11. Next, for the secondary diagonal, don't change the elements, just change the sign of the elements. A12 will become minus A12, A21 will become minus A21. That's it. That's all you have to do. Let's apply it in a question. Okay. So if A matrix is this, adjoint of A matrix will be simply, no need to find out cofactor, directly you can write adjoint of the matrix. Okay. So adjoint of the A matrix will be 10 will go here, 16 will go here. So 16 here, 10 here. Next, 12 will become minus 12. 14 will become minus 14. That's it. This is the adjoint of the matrix in one single step. No need to find out cofactor. Only for 2 cross 2 matrix. Okay. Next important formula that you should remember is, if you multiply a matrix with its adjoint, it will result in the determinant of matrix multiplied with identity matrix. Remember identity matrix, if it is a 3 cross 3 matrix, it will be 1 0 0 0 1 0 0 0 1. Remember I matrix? So determinant into I matrix is same as the matrix multiplied with its adjoint. Okay, let's prove it with a matrix. Verify that matrix into adjoint of matrix is same as determinant into I matrix. First of all, step number 1. What is adjoint of A matrix? Adjoint of A matrix will be interchange minus 6, 2, sign change minus 3 plus 4. This is adjoint of the given matrix. Okay. Now, A into adjoint of A is basically 2, 3 minus 4 minus 6 multiplied by minus 6 minus 3, 4, 2, which is basically 2 6 12, 3 4 12. Then you have 2 3 6, 3 2 6, 4 6 plus 24, minus 6 into 4 minus 24. Then minus 4 into 3 plus 12, minus 6 into 2 minus 12. Okay, so this is A into adjoint of A, which is equal to 0 0 0 0. So this is my left hand side. Okay, now on the right hand side I have determinant of A into identity matrix. Now what is determinant of A? Primary diagonal, 2 into minus 6 minus 3 into minus 4, right? This is determinant of the matrix multiplied with 1 0 0 1 matrix. 2 6 are 12 minus 4 3 are 12 into 1 0 0 1. So which is minus 12 plus 12 into 1 0 0 1. So which is 0. Minus 12 plus 12 is what? 0. 0 into identity matrix is what? 0 0 0 0. This is my right hand side. Hence proved. What is your left hand side? 0 matrix. What is your right hand side? 0 matrix. So this implies that LHS is equal to RHS. Hence our statement is proved. Alright. Next, some important properties of adjoint of a matrix. These are very important formulas. They are highly used in your competitive exams, not in your board exams generally. Okay, first formula is, what is the determinant of adjoint of a matrix? Is it equal to determinant of a matrix? No, it's not same as determinant of a matrix. So determinant of adjoint of A is basically determinant of A to the power of n minus 1. Now what is n? N is basically order of the matrix. N is your number of rows because and number of column. Because for a square matrix only we find determinant, right? Next, what is adjoint of a matrix? Adjoint of adjoint A. How will you find out? The formula is determinant of A to the power of n minus 2 into A matrix. Okay. Similarly, what is the determinant of this matrix? Determinant of adjoint of A is determinant of A to the power of n minus 1 whole square. These are the shortcut formulas to find out determinant of adjoint of A, adjoint of A, and determinant of adjoint of A. Okay, chalo. Let's apply this in a question. If your A matrix is given, what is determinant of adjoint of A? Determinant, first of all, we will find out what is determinant of A matrix. Determinant of A matrix is 2 into 8 minus 2 into 6. 8 2s are 16, 6 2s are 12. So this is 4. Now determinant of adjoint of A matrix will be determinant of A to the power of n minus 1. Now what is n? This is a 2 cross 2 matrix. So n value is 2. N is equal to 2. It's a 2 cross 2 matrix. So 4 to the power of 2 minus 1. That is 4 itself. So we have determinant of adjoint of A matrix is 4. Clear to all of you what you are going to do here? Awesome. Next, some more properties related to adjoint of a matrix. What is adjoint of A transpose? Is it same as adjoint of A whole transpose? Yes, it is same. So adjoint of A transpose is same as adjoint of A whole transpose. Adjoint of a scalar multiplied with A matrix is k to the power of n minus 1 into adjoint of A matrix. Okay. So adjoint of Ka will be k to the power of n minus 1 into adjoint of A. Similarly, adjoint of A to the power m will be nothing but adjoint of A whole to the power of m. And remember, this is very, very important. Adjoint of A into B matrix is equal to adjoint of B into adjoint of A. Here order matters. Remember, don't write A into B. It will be B into A. Okay. Moving on to some questions. Something jumbled up. If P matrix is this, give me just 1 second. I'll edit it so that you can read it properly. Mm, okay, hope it is little better. All right. Oh, so we have, if this is a P matrix, it is adjoint of a 3 cross 3 matrix A, and determinant of A is 4, then alpha is equal to dash. Now here we are going to use the formula of determinant of adjoint of A matrix is equal to determinant of A to the power of n minus 1. Okay. Now what is determinant of adjoint of A? This is basically adjoint of A matrix. How will you find determinant of this matrix? Just how we normally find determinant, right? So this is basically 1. 1 multiplied with 4, 3 into 4 minus 3 into 4 minus alpha multiplied with, alpha will be multiplied with what? Alpha. So it will be 1 into 4 minus 3 into 2. Similarly, plus 3 multiplied with 1 into 4 minus 3 into 2. Let's find the value. 4 3 is 12 minus 4 3 is 12. 0 minus alpha into this is 4 minus 6. 4 minus 6 is minus 2 plus 3 into 4 minus 6. Again minus 2. Okay. This is equal to determinant of A to the power of n minus 1. What is determinant of A? 4. 4 to the power of 3 minus 1. Why? Because n is equal to 3. It is a 3 cross 3 matrix. So we have here finally 2 alpha minus 6 is 4 square. What is 4 square? 4 square is 16. So we have 2 alpha minus 6 is 16. 2 alpha will be 16 plus 6. So 2 alpha is 6 2's 12, 22. Alpha will be 22 divided by 2, that is 11. This is my answer, that the value of alpha is 11. Understood what we did here? First we are finding out adjoint of A determinant and then equating it to determinant of A to the power of n minus 1. Alright. Next is, what do we understand by singular and non-singular matrix? Again, this is very important. They are asked in CUET exam a lot. What are singular matrix? A square matrix A is said to be singular. Remember, it should be a square matrix, okay? It is said to be singular if determinant of A is equal to 0. For example, if your A matrix is 2, 4, 6, minus 7, 8, 9 and 1, 2, 3, then the determinant of A matrix will be 0. This implies that A is a singular matrix. Okay, next, non-singular matrix. A square matrix A is said to be non-singular if the determinant is not equal to 0. So, if your matrix is of the form, let's say 1, 6, 4, 5. So, this implies that determinant of A is 5 ones are 5, 6 fours are 24, which is minus 19. So, determinant of A is not equal to 0. This implies that A is non-singular matrix. Simple? Easy? Very good. So, till now we have seen how do we find out adjoint of a matrix, determinant of a matrix, and how do we apply it in finding out singular and non-singular matrices. So, here is a quick homework question for all of you. Comment the answer in the comment section below. Okay. Moving on to some important theorems of adjoint of a matrix. First of all, if A and B are non-singular matrices, means determinant of A is not equal to 0 and determinant of B is not equal to 0, then AB and BA are also non-singular matrices. This implies that determinant of A into B will not be 0 and determinant of B into A will not be 0. Okay. Similarly, if the determinant of the product of matrices is equal to the product of their respective determinants. This means what? Determinant of A into B is equal to determinant of A into determinant of B. It is also equal to determinant of B into determinant of A. Order does not matter. Only if you are finding out determinant of the product. Okay. Next is, how do we find out inverse of a matrix and what is inverse of a matrix? So basically, if you have a matrix A, then A inverse is a matrix which when multiplied with A results in identity matrix. So if A is a square matrix of order n cross n, there exists another square matrix B of same order n cross n such that A into B is equal to B into A is equal to I matrix, and B is called as inverse of A. So if A, it basically means that A multiplied with A inverse is equal to I matrix. I is identity matrix. Okay. Now what is the formula for finding out A inverse? Now this is basically the concept of A inverse. But how do you find out inverse of a matrix? The formula is A inverse is equal to adjoint of A matrix divided by determinant of A matrix. So which is basically 1 upon determinant of A multiplied with adjoint of A matrix. It will be a matrix, of course. It will not be a single value, right? Okay, some theorems related to it. A square matrix A is said to be invertible if and only if A is a non-singular matrix. Means what? A inverse exists if and only if determinant of A is not equal to 0. Obviously, if the determinant is 0, then 1 upon determinant will be 1 by 0, undefined, right? So, A inverse exists if and only if determinant of A is not 0, right? Now, a quick question for you. if this is a matrix, find out A inverse. Let's understand with an example how do we find A inverse. Okay. First of all, we need to find out adjoint of A matrix. For adjoint of first, see, for A inverse, you need adjoint of A. For adjoint of A, you need cofactor of A matrix. Okay. So if A matrix is this, Cij will be what? Cij matrix will be, let's find out. For 1 we have 4 4s are 16, 3 3s are 9, 16 minus 9. Similarly, now I am going to do it directly because you guys already know. For 3 we will have 4 1s are 4, 3 1s are 3. 4 minus 3, 1. Next we have for 3, 3 minus 4. Next 1, we have 4 3s are 12, 3 3s are 9. Next for 4 we have 4 minus 3. For 3 we have 3 minus 3. And last row, for 1 it is 3 3s are 9, 4 3s are 12. Next for 3 we have 3 minus 3, and lastly for 4 we will have 4 minus 3. So the cofactors are 16 minus 9 is how much? 7. 7. 4 minus 3 is 1. 3 minus 4 is minus 1. 12 minus 9 is these are basically cofactors of A matrix, right? You have cofactors of the A matrix. So this implies that adjoint of A matrix will be transpose of the given matrix Cij transpose. So therefore adjoint of A matrix will be 7 1 minus 1, 3 1 0 minus 3 0 1. Simple. Now we need to find out determinant of A matrix. Okay. Determinant of A matrix is basically Aij multiplied with Cij. Right? So take any one row. For example, I am choosing row number 1. Okay. So 1 3 3 multiplied with 7 1 minus 1. So 1 into 7 plus 3 into 1 plus 3 into minus 1. So 3 1 into 1 and 3 into minus 1 cancel. The determinant is coming out to be 7. Okay. No, my mistake. Sorry, I'm so sorry. You have to first check the sign of the cofactors. Sorry, I missed sign of the cofactors. So C11 positive. This will be positive, negative, positive. Okay. Again, this will be negative, positive, negative. So minus 0 is same. Again, this will be positive, negative, positive. So no sign change. So here we have only one sign change. That is, it will become minus 3. Okay. Now let's correct it in the adjoint also. This will be minus 1 and this will be minus 3. Okay. Now we need to find this. So it will be 1 into 7 plus 3 into minus 1 plus 3 into minus 1. So we have 7 minus 6 is equal to 1. So the determinant is coming 1. Okay, determinant of A is coming 1. So therefore A inverse will be, A inverse is adjoint of A divided by determinant of A. So determinant of A is 1, so does not matter. 7 minus 3 minus 3 minus 1, 1, 0, minus 1, 0, 1. This is my answer. Because if you divide by 1, still you will get the same answer. Right? Okay, now next let's learn about the application of determinants and matrices. So, determinant is basically used to find out consistency of a system of linear equations. How do we do that? So, if you have a system of linear equation, 2 linear equations, 3 linear equation, 4 linear equation, and if you want to find out solution and the consistency of the system, then basically you need determinants for your use. Now, what do we understand by consistent system? If solution exists, okay, and what are inconsistent system? Where solution does not exist or is infinite. Okay, so basically if you have a 3 linear equations of the form a1x plus b1y plus c1z is d1, a2x b2y c2z is d2, a3x b3y c3x is d3, and if you want to know what is the value of x, what is the value of y, what is the value of z that satisfy all the 3 equation, then we can use determinants to find this. How? We can represent this as product of two matrices A1, B1, C1, A2, B2, C2, A3, B3, C3 multiplied with X, Y and Z will give you the equations, and on the right hand side you will have D1, D2, D3 matrix. Right? So this is product. This is how we can represent it in the form of matrices. Now how to use this to find out value of XYZ? So basically we know that A into X is B matrix. This implies that X will be A inverse into B matrix, right? This A will come here, so it will become inverse now. So when we want to find out the value of XYZ, we basically need to do what? We basically need to find A inverse and multiply it with B matrix to get XYZ value. Alright, now how do we determine whether our system of equations are consistent or inconsistent? Here is the solution. If determinant of the given A matrix, which matrix? This matrix. If the determinant of this matrix is not 0, that means inverse exists, that means solution exists, and we will have unique solution, consistent system of equations. Okay, if determinant is 0, this implies that A inverse does not basically exist, right? Now after this you have to basically understand that determinant is 0, but is adjoint of A into B also 0 or not 0? If it is not 0, then you can directly say that no solution exists and it is inconsistent system. If adjoint of A into B is also 0, then you can say that infinitely many solutions exist or no solution exists. We can't decide. Okay, so it is inconsistent. It is only consistent when you have a unique solution. That means you are able to find out xyz value. Alright, let's apply it to a question. Solve the system of equations given over here. Now these equations can be represented as 2, 5, 3, 2 multiplied with x and y resulting in 1 and 7. So x, y will be equal to 2, 5, 3, 2 inverse multiplied with 1 and 7. Okay. Now how do we find inverse of this matrix? Pretty simple. Let A matrix is 2, 5, 3, 2. So adjoint of A matrix will be, now this is a 2 cross 2 matrix. We can apply shortcut. Interchange the row. 2, 2. Change the sign. -5, -3. That's it. That is adjoint of the matrix, right? Now, after finding adjoint, you need determinant of A matrix. Determinant is 2 2s are 4, -5 3s are 15. So, it is -11. So, now x and y are basically equal to 2 -5 -3 2 multiplied with 1 and 7 divided by -11. Okay. So first of all, we will do matrix multiplication. It is 2 1s are 2, -5 into 7, 7 5s are 35. -3 into 1, -3, 7 2s are 14. So x and y are equal to this divided by -11. Now 2 minus 35 is, x and y are equal, 2 minus 35 is -33 and this is -11 divided by -11. So we will basically get x and y are equal to 3 and 11, right? So when we equate the matrix, this implies that x is equal to 3, sorry, not 11, this is 1 here. So this implies that x is equal to 3, y is equal to 1. This is solution of the given equations. Understood, everybody? How do we apply determinants to find out solution of system of equations? Okay, guys. So, if you have understood everything till now, I'm sure you'll be able to solve this homework question as well. Quickly comment the answer below and we'll see whether you're able to understand everything nicely or not. Okay, so coming to the end of this chapter and also end of the class, let's summarize what did we learn today. We have learned about adjoint of a matrix, finding inverse of a matrix, and application of determinants and matrices. Now, what is adjoint of a matrix? It is basically transpose of the cofactors. What is it? Cofactor transpose. These are the properties related to adjoint of a matrix. Now, what are singular matrices? Where determinant is not 0, and non-singular matrices where determinant is 0. Okay, sorry. Singular means determinant is 0, non-singular means determinant is not 0. Now, a square matrix can only be invertible if it is a non-singular matrix. That means the determinant is not 0. Now, how do you find inverse of a matrix? Inverse of a matrix is adjoint of A divided by determinant of A matrix. Now, here we have a system of linear equations which can be solved by using inverse of a matrix formula. If A matrix is this, X matrix can be represented to find X, Y, Z the variables, and B matrix are the right hand side elements. Then X is basically equal to A inverse into B matrix. Okay. Now, when do we say that our system of equation is consistent or inconsistent? If determinant is not equal to 0, there exists unique solution. If determinant is 0 and adjoint of A into B is not 0, then there exists no solution. If determinant is 0 and adjoint of A into B is also 0, then may or may not be infinite solution. Alright, so this is all that we have in determinants chapter. We have completed it. So I'm sure you'll be able to solve now each and every type of question that comes from this chapter. Okay, so if you want notes of today's lecture, please join our Telegram channel. We provide with you all the notes, all the important informations and notifications of every class over there. And if you're somebody new on the channel, do not forget to subscribe for regular lectures of +1 and +2 of physics, chemistry, maths, and biology. Thank you so much, everyone. Have a wonderful day. See you tomorrow with another chapter. Take care. Bye bye. Bye, guys.